Hi, hello my dear kids. Welcome back to my YouTube channel, and I am here with the next chapter of Chemistry Class 10th portions. This chapter is based on metals and non-metals and an important chapter. A very small chapter but is important with respect to the concept clarity. Metals, let us quickly start this. First, let us understand what are we going to cover in this chapter. In this chapter, the physical and chemical properties of metals and non-metals will be done, as well as we are going to explore the chemical properties and their behavior with daily life scenarios. These are the important things that you have to understand in this particular session. First, moving on to physical properties of metal. What is a metal? Metal is hard, it's malleable, ductile, has high density, and is a good conductor of heat and electricity. See, the board is made up of a metal. It's hard. It can be shaped. So we say metal is hard. It can be beaten into wires. It can be beaten into sheets. It can be converted from one form to another form. So it also produces sound. So the technical terms here are important. Malleable is the term important. Ductile is the term important. It has high density because it can be converted in the shape format. It should have density. We have metal boards, we have metal stands, chairs, and many other components and shapes are made of metal. So metal should have high density. Obviously, we all know that the electrical wires are made up of metals like copper, aluminium, etc. Therefore, metals are good conductor of electricity. Due to that reason only, it is converted into wire. Example, gold is the most malleable metal. If we are coming to the scenario here, according to the property, let us check. Gold is most malleable metal, while copper is an excellent conductor of electricity. Just now I told you, wires are made up of copper. The conductive metal is gold, but it is costlier. So we normally use aluminium and copper to conduct electricity. So this is the physical property of a metal. Just within 2 minutes you can memorize this. Moving to physical properties of non-metal. Now we got to know what is a metal. Let us see what is a non-metal. Non-metal are brittle. That means they are not too hard. They are non-conductive. They don't conduct electricity. They exist as solid or gas, except bromine, which is a liquid. The only non-metal which is liquid is bromine. Apart from that, all non-metals have solid or gaseous state. So when we come to the properties of metal, non-metals are non-sonorous, non-ductile, non-malleable, all ulta property of metal. See, name is itself non. Metal का opposite जो भी है उसको हम non-metal बोल देंगे. ठीक है? So non-metals have these properties. Some examples: sulfur, pH. Sulfur and iodine are solid non-metals, while oxygen is a gaseous state non-metal. So some examples of non-metals are given here: sulfur and iodine, which is in solid state, and oxygen, which is in gaseous state. Let us now understand what is the chemical property of metal. See, our motto is to understand the concept and learn properly. So first we learnt about physical property of both metal and non-metal. Now we are focusing on chemical property of metal and non-metal. The first chemical property says metal forms oxides that are basic in nature. If I take an example here, the metal, if the name of the metal is sodium, sodium plus oxygen gives me Na2O. So Na2O is basic in nature. Same way, any metal, if you add, the general form will be metal plus oxygen gives metal oxide, which is basic in nature. Second chemical property, metal reacts with acid to produce hydrogen gas. Example can be here, Mg plus HCl gives MgCl2 plus H2. Mg is a metal, it is added with hydrochloric acid, displacement reaction is happening, and it's forming magnesium chloride, a salt and a hydrogen gas. General form will be metal plus acid is going to give me salt and hydrogen gas. So the general forms of any chemical property of metal is very important. In this screen, you have learned two important chemical properties. The first one was any metal added with oxygen gives you metal oxide. The metal oxide is basic in nature. The second example is any metal added with an acid gives you salt and hydrogen gas. So general form I have written with an example for both the scenario. This is chemical property of metal. Moving on, let us see the chemical properties of non-metal now. Not to get too much confused, in simple scenario I am explaining you the concept. So let us learn the chemical property of non-metal. Non-metal normally forms oxide which are acidic. See, metal form basic oxide, non-metal will form acidic oxide. So if I have a non-metal sulfur, if it is reacting with oxygen, it gives me sulfur dioxide which is acidic or neutral in nature. So general form will be non-metal plus oxygen gives you non-metallic oxide which is acidic in nature. Second chemical property will be non-metal do not react with acid. This is the most important one. Non-metal do not react with acid. They do not displace hydrogen to form dilute acids. This is an important activity important chemical property which helps you to understand that non-metal will not react with acid, because when non-metal are there in the oxide form, it's acidic in behavior. Again, how can it react with acid? That is the reason non-metals do not react with acid. For example, if you have sulfur plus oxygen, as I told you, the first chemical property is represented in the form of a reaction here. So this was the chemical property of non-metal. Now let us learn a simple thing called as reactivity of metal using activity series. Metals can be arranged in decreasing order of reactivity. Most reactive metals like sodium, potassium are at the top. Most reactive metals are at the top and least reactive are at the bottom. See, the reactivity series is arranged from potassium to platinum from top to bottom. The metals are arranged in decreasing order of their reactivity. If I take the first element called as potassium, it can react with all the elements that is below. If I take the middle one, copper, it cannot react with the upper order element, but it can react with the lower order element. So based on the upper position, the reaction will happen. So looking at that, we are going to understand whether the reaction is going to happen or not. That is called as reactivity series of metal. Based on that only, the displacement reaction is going to happen. Alright. So most reactive metal can displace less reactive metal from their salt solution. If I have Fe, the reaction is written here, Fe plus CuSO4, it gives me FeSO4 plus Cu. Where is iron placed? Iron is placed here and then copper is here in the reactivity series. Let us consider this as the reactivity series. All the elements are arranged from top to bottom. First is potassium, sodium, zinc, aluminium, magnesium, etc. are coming down. So since iron is more reactive than copper, this iron can displace copper. So iron is coming and taking the position of copper. So FeSO4 plus Cu is happening. If this reaction was ulta, Cu plus FeSO4. See, copper is lower order reactive than iron. So this reaction cannot happen. No reaction is possible here because copper is less reactive than iron. So displacement reaction completely relies on the reactivity series of the metal. The metal who are capable or having more reactive are more reactive than the lower order element. They can displace the element from the compound. That is the concept here. This is called as displacement reaction of metals. If I have to extract the ores from the metal. Extraction of metal from ores. What are ores? Ores are the big rocks that are present deep inside the earth or deep inside the mountains. The rock format of the ore is taken and from there the ore has to be purified. So they are called as minerals. The minerals have to be purified, removing all the dirt, dust and various other things by various process. So extraction of ore in this chapter is an important topic. Metal are extracted from their ore depending on the reactivity. There are various types of metal ores, so they have to be extracted based on the reactivity. because if I use different reactivity, different format for higher and lower reactive elements, it will be easier for me to separate the ores from its rock. So high reactive metals like sodium are extracted by electrolysis. So high reactive metals are extracted by electrolysis process, while less reactive metals are extracted by reduction process. Two important things. If it is more reactive, I will use electrolysis process. If it is less reactive, I will use reduction process. This you have to keep it in your mind. Now, when after extraction, so till now what and all I have covered, my dear kids? From the beginning, physical properties of metal non-metal हो गया. Second, chemical property of metal non-metal हो गया. Reactivity series. Then we have covered displacement reaction. Then purification of ore. If it is a higher reactive metal, which type of technique, and low reactive metal, which type of technique. Now, what are ionic bonds? In this chapter, we have a concept called as Levi's dot structure. So, Levi's dot structure is completely based on ionic bonds. Whenever an element is combining with another element, there are two types of bonds formed. One is called as covalent bond. The second one is called as ionic bond. Ionic bonds are only formed between a metal and a non-metal, and that too by transfer of electrons. Electrons are either lost or gained. That is called ionic bonds. So the first point, more metals lose electron to form positive ion, and non-metal gain electron to form negative ion. Let us understand the formation of sodium chloride. Okay, sodium, the symbol is Na. The atomic number is 11. So electronic configuration will be 281. Sodium's electronic configuration is just drawn here. Sodium has to lose this one electron to attain stability. So it is losing one electron. Now let us think of chlorine. Chlorine atomic number is 17. Electronic configuration is 287. It has to gain one electron. So in chemistry, whenever an element is losing electron, it attains a positive charge based on the number of electrons lost. One electron lost, one positive charge. Two electrons lost, two positive charge. Same way, chlorine is gaining one electron, so it will have one negative charge. So this one electron which was there with sodium, this is transferred to chlorine in order to make the outermost orbit completely stable. That means sodium is giving away one electron, chlorine is gaining one electron. So one electron lost by sodium, making it Na plus, and one electron gained by chlorine is making Cl minus. So the chemical formula or ionic bond formed here is Na plus and Cl minus. We call them as radicals, sodium radical and chlorine radical. Na is gaining a positive cation and chlorine is gaining a negative anion. So what is an ionic bond? Electrons that can be lost or gained by any element to form a compound is called as ionic bond. Whenever electrons are lost, electron can only be lost by metals. Whenever electrons are gained, electrons can only be gained by a non-metal. Therefore, loss of electron makes the metal positive. See, sodium is a metal, it is becoming positive. It is called electropositive element. Chlorine is a non-metal, it is becoming negative. So, it is called as electronegative element. So, this type of bond formation is called as ionic bond formation. There are many different examples given in the NCERT textbook, like formation of MgCl2, formation of calcium fluoride, formation of sodium oxide, and various other important compounds you have to study. Okay. Moving on to next concept. What is the property of ionic compounds? First, ionic compounds are solid. They have high melting and boiling point. They are solids, have high melting and boiling point. They are good conductors in molten state, but not in solid state. See, not in solid state. In solid state, they don't conduct electricity. Only in molten state, they conduct electricity. Sodium chloride is an example given. It dissolves in water to conduct electricity. So if sodium chloride is there in the solid form, it will not conduct electricity. When dissolved in water, it conducts electricity. These are the properties of ionic compound. So moving on to the next concept of the chapter called as alloys and their uses. What are alloys? Alloys are basically mixture of metal and non-metal that enhance properties like strength and corrosion resistance. Like I am taking some amount of iron, taking some amount of aluminium, nickel and cobalt. So I get an alloy called as brass. So whenever I am adding 2 to 3 metals in a particular ratio, I get a new thing called as an alloy. Stainless steel is an alloy. So what is the combination of stainless steel? I have iron in it, I have chromium, I have nickel in it. Yeah. So the combination of these three is giving a beautiful compound called as an alloy stainless steel, which is nowadays used in many sectors. We have stainless steel staircases, pipes, vessels, stoves, etc. So alloys are really important because when 2 or 3 metals are mixed like this, it is avoiding rusting. So to avoid rust, previously we used to galvanize or paint. That is not necessary at all now because we have a new component called as stainless steel. There are many different types of alloys also and many different combinations of metal to get the alloys as well. Next is what is meant by corrosion. Metals like iron, okay, they corrode when exposed to air and moisture. The important concept is called as rusting. When iron is exposed to oxygen or water, it forms Fe2O3. This Fe2O3 is called as rust. Whenever the oxide form or the water, moisturous form of iron is there, I get rust. This is a very slow process. It can happen even in months or in years. When you paint any iron article on it, the rust can be avoided. So prevention is painting, galvanizing or alloying. These are the 3 things through which we can avoid corrosion or rusting. Rusting of iron has importance even in the atmosphere as well as it has importance based on the chapter weightage of marks as well. So now certain important questions which I feel you have to answer. Why is sodium stored in kerosene? Try to figure out the answer and comment below the answers for me. Write the balanced equation for the reaction of magnesium with hydrochloric acid. If you have seen the video in a very nice and attentive manner, you will be able to figure out the answers for this. Comment below the answers for me, and I hope this video was really informative and helpful for all my kids. Don't forget to subscribe my YouTube channel for further updates on these kinds of videos. Thank you so much for watching.